This is the first of our bonus videos. I'm going to be making some updates to the CPU. You can also work through some updates yourself, and you could use these videos as a guide as to how you can change the CPU to make it a little bit better, because it's not a finished article. We can continue improving on it. So let's have a look and see what I've done in this video. So the loading of the CPU was always a bit clunky and not very elegant, so I've simplified it a little bit. So if you were to open up the design, which is in the resources section called CPU_design_bonus, then if you were to get in there and reset the simulation, so you'll notice here that there's just one single reset button, so you just press reset and that's it, ready to go. Then you can right click, edit contents, and then you can open up the contents from your file. So that's loaded in, and now all you need to do is just press the run, so tick enable, and we don't need to worry about the clock or the position of the clock, and it will tick and count through to a value of FF. So I'll get you back here in a second whenever it's finished. So that's actually loaded it up, and it instantly just jumps on and starts working through the simulation. So it's put 5 and it's put 5 in, so the answer here will come out as 19 in a few seconds. So you can see that's it finished, so we can get in and we can stop the tick. So that's it completely finished now. So let's go down into the CPU. We'll have a quick talk through and see the changes we've made in order to make this work. So really the changes are within the control section. So what I've done in the control section is introduced a new instruction. The new instruction is going to be all zeros. So this is an instruction that wasn't getting used, and we know that whenever we initialize the CPU, there's a 0 in the first byte of the RAM, so we can use that in order to initiate the load. So if these are all 0, then I've taken a output from here, so they're all coming in as 0. They go through an AND gate, and then they go through a NOT gate. So when this instruction comes in at zeros, we get a 1 out here at the load, and this controls the flow of information round about our control unit. So we've got this split here with the AND gate that stops the stepper from actually counting, and this will be dependent on that value for the load. So if it's all zeros, we get a high coming out here. But that's not the only thing we have to take care of. We have to look at the fact that we only want this to happen for 256 clock pulses, because we're going to load up 256 bytes. So we have to have this value 256 coming from the counter as well, back in here and get through the AND gate. And you can see here the place where we had the memory address register, it can be picked up from this point L1. Okay, and also the point down here for the RAM set can be picked up from point L1. So we don't need to bother doing these are taken care of automatically. Now, it's not necessarily the best way of doing it. There's smarter ways of doing it, but we could sit down and at some point in the future I'll work through some other examples. So for example, I could have the output here heading up, and I can control these sets and enables directly from this output via some AND gates, and there are other options there. So a good thing to do as well is you could take this design and you can mess about with yourself, and you could take your own make your own instructions up and redesign this and add sections on for your own instructions. So lots of stuff that you can do in this, but I think that this certainly makes the CPU run a bit easier, and you're a lot less prone to make mistakes whenever you're going and setting the CPU up from the beginning. So that's all there is for this video. Thanks for listening. I'll get you on the next bonus video. Goodbye.